Alright, welcome. We're on the last kind of part of our journey through matter, solutions, and solubility. We've seen this slide before, but necessary to start here. When we talk about solutions, remember they have two parts. A solute, which is going to be the substance that is dissolved, and the solvent, the substance that is doing the dissolving. With the two pictures below, which one is the solute and which one is the solvent? Hopefully you say that the solute, the substance that is dissolved, is going to be the sugar, and the substance that is doing the dissolving is going to be the actual water within the Kool-Aid. Right, so the sugar we put in Kool-Aid is dissolved, the solute, which is dissolved within the water, the solvent. Alright, moving on. Alright, remember we have many different types of solutions. Okay, don't be tunnel visioned into thinking that the only solution there is a solid and a liquid. We can have a solid and a solid, we can make a brass, we can have a liquid and a liquid, vinegar and water, we can have a gas and liquid soda. There are many different types. Okay, now we've done an online lab and now we've done an actual lab looking at potassium nitrate and sodium chloride. Some of us had to do the lab twice, but dissolution or dissolving is affected by three things. Okay, one is temperature, another is stirring, and a third is increasing the surface area of the solute. Okay, so we saw within the lab that as you increase the temperature, we can actually dissolve more. We can actually fit more stuff in. If you stir it, you're going to be able to dissolve more, such as if you made your Kool-Aid and you just poured the packet in, well, you got to stir it up in order to increase the dissolving. And increasing surface area, that would be like if we had a chunk of sugar and we decided to take a hammer. Oh boy. There, that's pretty good. Take a hammer and smash it into little pieces. Now, instead of having one sugar cube that has 6 sides, we now have lots of sugar cubes. We're increasing the amount of surface area, which is going to increase the dissolving rate. Okay, so we're going to talk about two types of solutions. One, which we're most familiar with, is solid and a liquid. Okay, the solubility is going to increase with temperature. And remember, when we talk about solubility, we are talking about the amount of solute that we can fit within 100 milliliters of water. So, in the instance of Kool-Aid, we're talking about the amount of sugar, the amount of solute that we can fit within 100 milliliters of water of our Kool-Aid. Okay? So if we were to heat up our Kool-Aid and then add more sugar, we could actually fit more sugar within the Kool-Aid. And then the rate of dissolving, so how fast it's going to dissolve, is going to increase with stirring. And you see that with Kool-Aid. If you let it sit there, it's going to dissolve very slowly. If you take a wooden spoon and you start stirring it up, it's going to dissolve a lot faster. The other type that we're going to look at is a gas in a liquid. Okay, that would be kind of like a soda. Okay, you can see the can of Coke down there. Okay, the solubility, or the amount of, in this case, gas that can fit within 100 milliliters of liquid, will decrease with increased temperature. Okay, so how does that compare to a solid in a liquid? Well, let's go back. We see a solubility increases with temperature with solids, and with gases, solubility is going to decrease with temperature. Okay, so they're inverses. And the solubility will increase with increased pressure. Okay, now, if you think about it, you open up a can of soda, you pop it open, okay, you hear that sound of pressure being released when you pop the can open. You take the first sip and it tastes real good. And you let it sit there for an hour. Well, what happens to the temperature of the liquid within the soda as you let it sit there for an hour? well, the temperature is going to go down. Okay? So as your temperature increases, because hopefully you had it nice and cold in the fridge, so as the temperature increases to room temperature, the solubility of that gas, the carbonated gas, is going to decrease. So you take a sip after an hour and maybe it starts to taste a little flat. It doesn't taste as good anymore. That's because as your soda warms up, as the temperature increases, the carbonated gas, you can't fit as much in there anymore. So you're actually going to have less carbonated gas in there, and it's going to taste flat. Which is why they pressurize it inside a can so that they can fit more gas. So increased pressure, more carbonated gas means a better tasting soda. Whoa! Alright. This is a solubility graph. So we have all kinds of different substances on here, and we are going to use this to actually look at how to analyze whether a substance is saturated, unsaturated, supersaturated. I have some other things. I won't ask you any questions here, but you will have several sheets that you'll be doing to get practice. But in a solubility curve, on the left side is going to be grams of solute per 100 grams of water. So in other words, this is the solubility. This is how many grams you can fit in 100 grams of water. And then on the bottom, we have temperature. All right? Now, the temperature goes from 0 to 100. Now, why does the temperature go from 0 to 100? Why do you think the temperature goes from 0 to 100? Well, if we think about it, we are testing how many grams of solute in water. Well, what happens to water when it gets to 100 or above? It starts to boil. It starts to turn into a gas. We no longer have a liquid. That's going to be tough to fit stuff into that gas. And what happens below? Well, it starts to turn to ice, starts to turn to a solid. Again, we have that problem. We're only looking at solubility in water when it's a liquid. So 0 to 100. Okay. What do you notice about the trend between gases and solids? Okay, take a look at the legend and take a look at your graph. What do you notice about the trend? Okay, and then quickly, thing we went over the other day, we can call solutions 3 different things. They can either be saturated. A solution cannot dissolve any more solute under the given conditions. If more of it is added, it's just going to settle to the bottom. So that's like you have your thing of Kool-Aid and you fit the max amount of sugar in, and if you put 1 more gram of sugar, it's not going to dissolve, it's just going to settle to the bottom. Unsaturated means that, hey, Kool-Aid says, give me more, give me more, give me more sugar. It's not. It contains less solute than the maximum amount, so it can fit more. And then supersaturated holds more solute than it should be able to hold. And it does this because we changed its conditions, like we did in the lab. You should have seen some of the beakers looked like this. We had some crystallization happening because we fit more solute in than we should have because we increased the temperature. And when the temperature came back down, it solidified. Right? So kind of like our pictures here. We have our undersaturated or unsaturated. This guy wants more solute and it shall dissolve. Our saturated guy is full. He can't dissolve anymore. And our supersaturated guy, well, when you increase his temperature, he can dissolve more than any ordinary substance. Okay, use this for a review, and also use this as a review when you're starting to work on some of the solubility graphs. Please let me know if you have any questions.